Hello, this is Gagan and Mukil. We will be presenting MediChain, a blockchain-based system for tracking medical supplies in crisis environments. The goal is to make shipment history tamper-evident by recording custody, lifecycle stages, and handling conditions on chain. In the next slides, I will cover the problem, our design, and how the system works end-to-end. In crisis environments, logistics data is often stored in paper trails or centralized systems that can be forged, lost, or edited during transit. This slide highlights the impact when tracking data is not immutable. You can lose accountability and directly compromise patient safety. This is the real problem we are solving because before we even talk about technology. Here is the main shift in design. Instead of trusting humans or intermediaries to maintain integrity, we rely on an immutable chain ledger. Once data is written, it cannot be altered, and smart contracts enforce rules that makes tampering evident by design. In simple terms, code becomes the verifier of the journey, not an organization or a database admin. The journey, lifecycle enforcement. This slide explains how we enforce the journey as a strict lifecycle. A package moves through defined stages like manufacturing, quality control, warehouse, in transit, distribution, and delivery. The important point is that transitions are atomic consequential, so you cannot skip steps and you cannot move backwards. This prevents rewriting history and ensures the chain of custody is consistent. The smart packaged IoT integrated. Tracking custody alone is not enough for medical supplies because handling conditions determine safety. So we capture cold chain monitoring, humidity range, shock detection, and GPS proof. The key message here is that these conditions become verifiable evidence tied to package record, not informal notes that can be disputed later.
So in this slide, I'm going to go over the multi-network architecture. So this is a summary of the system overview. The front end is a React and TypeScript interface that connects securely to wallet-based interactions, and the core logic lives in the smart contract. This uses an established security pattern and supports batch processing for cost efficiency. Finally, we support multiple EVM compatible networks, including testnets and layer 2 options. So the same system can run where cost and speed make sense. And here we separate duties with role-based control. An admin handles infrastructure and permissions. Operators do field entry data. Verifiers certify quality control. Viewers get visibility without the ability to change state. And the takeaway is that the system does not rely on trust in a single party because permissions are explicit and enforced at protocol levels. This slide compares two approaches. The legacy pattern is a sequential polling and heavy RPC usage, which increases latency and cost, especially when transactions spike. Our approach is event-driven, so the UI updates when events occur, and batching reduces overhead. This makes the system faster, cheaper, and more reliable for crisis scale operations. Healthcare depends on trust, but crisis logistics often involves many organizations that do not share perfect trust. The point here is that we remove the need for intermediaries by providing an immutable audit trail. Anyone with access can verify the same history, which makes accountability and dispute resolution far stronger. To close, this is where we show the system in action by tracking a package through its lifecycle. The demo focuses on the core story, creating a package, updating its lifecycle stage, recording custodial transfers, and capturing handling conditions. The final message is that we are securing medical integrity where it's needed most, using a design that stays verifiable even when environments are chaotic. Now over to Gagan for the code walkthrough.
Thank you for that, Mukul. So the first thing to notice here is the package struct. This is the on-chain representation of a shipment. It stores ownership, status, timestamps, and the handling evidence like temperature, humidity, location, and shock. The takeaway is that this record is not a normal database row. It's an immutable audit trail that only changes through contract rules. And these are the roles that are being defined. We separate responsibilities so not everyone can do everything. Admin manages permissions, operator manages operator performs field updates, verifier certifies, and viewers can only read. This matters because in real crisis supply chains, multiple parties exist and we enforce least privilege directly in the contract. Before I show business logic, notice the defense layer. We validate package IDs and inputs. We rate limits to reduce spam, and we protect state changing functions with re-entrancy guards. The goal is not just correctness, it is resilience because this system may receive high volume traffic during real instance. Now I will show create package. This is the entry point where a shipment becomes an on-chain object. Once it is created, the contract emits an event that becomes a permanent starting point for the package timeline. This is the moment the audit trail begins. And here is the lifecycle enforcement. We define stages like manufacturing, quality control, warehouse, in transit distribution, and delivered. The important part is update status. The contract enforces forward only progression. So you cannot skip steps and you cannot go backwards. That prevents someone from rewriting the journey later.
Now I will show transfer ownership. This represents a custody handoff. Only the current owner can transfer, the new owner must be valid, and the contract emits a transfer event. That event is crucial because later anyone can reconstruct a custody history directly from the chain logs without trusting an internal database. Beyond custody and status, we also record handling conditions. For medical supplies, cold chain integrity matters. These updates function These update functions let authorized roles record environmental evidence on chain, so temperature excursions or shock events become verifiable facts in the same audit trail. Now I will show create batch. In real logistics, you register many packages at once. Batch creation reduces overhead per package and makes the system economically viable, especially on low cost networks. It is a scale feature, not just a convenience feature. Now I'm switching to the front end. When a user clicks an action, the UI does not manually wire the contract calls anywhere. Instead, it uses one helper hook that exposes send transaction that helps that helper selects the correct contract address for the connected chain, triggers the wallet signature, and broadcasts the transaction. And now here is the core reason the UI stays consistent. We listen to on-chain events like package created and update the UI when logs arrive instead of polling repeatedly. We also fetch historical logs, so a page refresh can rebuild state from chain history. This keeps the app aligned with the blockchain, even if the front end was offline earlier. Blockchain event data is low level. This parser converts raw event fields into a clean UI object with readable status labels, timestamps, and structured description details. This is what makes the audit trail human readable without altering the underlying truth. The front end is configured to connect to multiple EVM networks, and it selects the correct deployed contract address depending on the chain. The deploy script is what produces the address after deployment, and that address is then wired into the front-end config. So the code story is simple. The smart contract enforces integrity and emits verifiable events, and the front end listens to those events to stay synchronized in real time without relying on a centralized database. And now I'm going to show you how that works in real time. This is our application MediChain. We are now connecting it to the wallet. And as you can see, it is connected to the wallet on the Sepolia test network. We are now creating a shipment on the blockchain for pills of 300 units. And now we define the origin and the destination for the shipment. The next step is we assign it to the handler and input the delivery date for the shipment. And then we go ahead and create the NFT. And we should be seeing an update on the platform with the transaction successful. We're just waiting for the blockchain confirmation. You can view the transaction on Etherscan as well. Here is the transaction for the shipment that we just created on the Etherscan portal. And there you go. We can see the transaction status as success. And the same will be reflected on the dashboard as well. So if you now go to all shipments, and we should be able to see it. We refresh. There you go. That concludes our demo of MediChain, our blockchain application that is catered to medical supplies in the crisis zone. Thank you.
Thank you.